Today we're in the AP packet, chapter 4, page 7, and we're going to be learning how to balance redox reactions by the half reaction method. The half reaction method is certainly not something I would recommend as opposed to the shortcut method, but sometimes a question is specifically going to ask you about the half reaction of oxidation or the half reaction of reduction. So what we're going to do is we're going to realize how to write those separately today. Again, we're going to follow the same steps that we did before with element, electron, water, and H+. It's the same reaction we did before. So I'm just going to quickly write down the oxidation numbers because we learned how to do this last time. And we're going to recall that the oxidation, of course, was the iron going up, and the Mn going down was the reduction. So what you're going to do now is you're simply going to pick out each part by itself. In this case, we're going to start with the oxidation. The oxidation was Fe plus 2 going to Fe plus 3. So I'm going to rewrite that here. Fe plus 2 going to Fe plus 3. Now what you're going to have to do is you're going to have to manually put in your electrons where they belong. Since this is oxidation, meaning we lose electrons, you should understand that a plus 2 going to a plus 3 lost 1 electron. And you can even look at it mathematically that a plus 3 and a negative 1 are going to equal a positive 2. So we actually just took care of the step of elements and electrons with this. Okay, so that step is now done. The next step is, again, use water for oxygen. There are no oxygens anywhere, so I could just skip this step, and I don't need it. And lastly, in this part, we're going to do H pluses for hydrogen. Again, there are no hydrogens at all. So we're done with the oxidation. So if they asked for the oxidation half reaction of this reaction, you would just write this and you're done. Now we're going to do the reduction half reaction. So here we have the MnO4 minus, and that's going to turn into Mn plus 2. So you're going to go down from plus 7 to plus 2. That's going down by 5, and you must have gained electrons to do that, so that's going to be plus 5 electrons. Remember, when you are reduced, you gain electrons. Now we're going to continue the process. So that was step element electron. Now we're going to do step water. There are 4 waters there, so we're going to put, 4 oxygens. So I'm going to need 4 waters here. 4 O's, need 4 H2O's for the O's. Lastly, you're going to do the hydrogens. We're 8 here and none here, so you're going to put 8 H pluses. And the last step with this, if you were going to, if you're going to use this method, I would only use this method personally to say what is the oxidation half reaction or what is the reduction half reaction. That's all I would ever use this method for. But if you were going to use this method to actually balance the entire equation, what you will need to do is you're going to need to make the electrons match in both. So to do that, you want this to match this. You'd have to multiply the top equation by 5. So this would be a 5, a 5, and a 5, and then this one stays multiplied by 1. And then when you rewrite the whole equation, you would see that it would all work out to be the same answer as the other notes. And the electrons would cancel out, for lack of a better word. So MnO4 minus plus 8 H pluses yields 5 Fe plus 3s plus Mn plus 2 plus 4 waters. So it's a little longer, but you could get the same answer. Now let's suppose we're going to do a basic solution. Same oxidation numbers as the last example we did on the other page. All right, so again, the reduction was the Mn going down. The oxidation was the Fe going up. So if we write the Fe going up, it's going to be Fe plus 2. Fe plus 2 yields Fe plus 3 and an electron on the right side. That took care of the element's electrons. That actually also took care of waters because there are no O's, and it actually took care of H pluses because there are no H pluses. Therefore, we didn't even need to use OH minus. So that was simple for the oxidation. The reduction half reaction is going to be the permanganate MnO4 minus. I'm going to give myself extra room here to go to MnO2. Again, we went from plus 7 down to plus 4, so that's only a 3 electron change. So that's going to be plus 3 electrons. All right, now what we're going to do is we're going to look at the H2O for balancing. So if I'm missing 4, I have 4 O's here and 2 O's here. I'm missing 2 on the right, so I'm going to put 2 H2O's there. And then I'm going to have to work with my H pluses now. So I have 4 on the right. I'm going to need 4 on the left. And then lastly, my OH minuses. I have 4 H pluses, so I got to match OH minus on both sides with 4. And then before I go any further, what I need to do is I need to get the electrons to match. So this has to match this, so I have to multiply the top one by 3. And by the way, if I had this problem, the only reason I would do this, again, is if they asked me a half reaction, and before I even tried to multiply these electrons, I would have been done already. Okay, so oxidation was what's in black here, reduction is here, and I would not need to do anything else. But if you wanted to make sure that they did add up, you would multiply the top equation by 3, and you would add this up. Let's remember what we did last time, that 4 H pluses and OH minuses make 4 waters. And if I have 2 waters and 4 waters, I can get rid of this one and turn it into a 2. And then when I write my final answer, I'm going to have 3 Fe plus 3s plus MnO4 minus plus 2 waters. And that's going to yield, because I'm done with that, yield MnO2 plus 4 OH minuses. And this is the exact same answer as we had on the page before with the shortcut method. So it gives you the same answer. It's a little extra work. The only use for this method is if they specifically ask you for an oxidation half reaction or a reduction half reaction. You do each one separately and still follow the same steps that we learned in balancing the regular reaction.